down. And those of you who have been charged with reminding me don't have to remind.
Good job.
Welcome those of you who are here, and I will keep watching for the rest who are arriving. We are delighted to begin our spring round of webinars. We had been doing them about once a month, took a little pause over the holidays, and we are so grateful for all of you for participating and hope that you all care about the watershed as much as we do. And I'm now going to turn it over to Madeline Fletcher, who is co-chair of our education committee, to introduce our speaker.
Yeah, thank you. And it is a real pleasure to be able to introduce Dr. Kirstin Dow. She's a professor of geography at the University of South Carolina, and she's been a real friend to the Gills Creek Watershed over the years. So it's just a delight to have you here, Kirstin. More important than your friendship to the GCWA, though, I think, is that you've been a real friend to us all for your life work as a social and environmental geographer. And your work is, I'll tell you know this, Kirstin, and I'm going to tell the other folks that your work is so highly regarded for its excellence. And that's evidenced by, for example, things that you've done on international and national committees and reports that you've contributed to on key climate assessment groups, such as the IPCC, but there are other examples. But then your work is also highly regarded for its excellence and its relevance to us, the communities of citizens, their lives, their cultures, their economies, and their environmental resources. And I believe you're coming to talk to us today about a little bit of that, give us a taste of that. And so I'm really looking forward to it, as I know we all are. And here you are, Kirstin, welcome, and looking forward to hearing you now.
Sure. Thanks, everyone. It's great to be here. Longtime fan of Gills Creek Watershed Association, and I see people from a number of other organizations that I've delighted to have gotten to know over the years. So I wanted to share what I've been thinking about lately more and more. It's not where I started my work. I started out thinking about, as I began getting involved with climate change here in South Carolina, it was more about drought. But as I've, that was 20 some odd years ago, and I continue to find new things to think about. And so I want to talk about this urban heat island issue. As I'm coming to understand it, heat is the most significant threat, health threat associated with weather in the United States, according to the National Weather Service. And when we think about climate change and where that is right now.
Kirstin, I'm sorry, can I stop you a second? Are you meaning to share your slides yet?
I am. Sorry, is it not sharing?
No, it's not.
Excuse me, that may have been me.
And Trish, while you interrupted for a moment, would you like to remind folks to submit questions?
Carmony put something in the chat reminding people to submit questions in the chat.
Okay.
And we'll take them at the end, except for if there's something important, like, do you think you're sharing slides? Because we don't see them, in which case we will take them.
Yeah.
In which case we'll let you know earlier. And all the setup I did to make sure that everything was in order has somehow gone astray. So let's just see here.
We tested it before and it worked. So it
it did.
Yeah.
So let's see if that's going to work. All right.
Promising. Yes. Yay.
Okay. So first slide, it's not our city. Excuse me. I did test it before and it did work, and now it wants to be difficult. So pardon me as we try and straighten this out.
if it helps, what's showing here looks like what it should be showing.
Yeah, yeah. All right. It's just not. Advancing the way it should. All right. Maybe we got it now. Okay. So urban heat island has become a greater and greater concern as we think about this. I can show you the map of Columbia. We've seen this kind of thing before. We know that that the temperature measurements and the increase in temperature is the most consistent indication of climate change in all of the models and in all the information we have about the various disruptions that are associated with climate change. Looking here at the summer average daily temperature for Columbia, we know it's hot, or for Richland County rather. It was 81 points. It's been 91.8 in last decades, but in the next 30 years are expected to go to 97, and in decades beyond that, up into 100. And it's not just the daily summer numbers, it's the overnight lows. You know how it is to get up in the morning and find that it's already 75 degrees and enormously humid. The expectation is that we'll see more of that under the higher emission scenario. Sorry, these are not matching. Under the higher emission scenario in the late 21st century, we'll see potentially maybe 100 nights of these higher temperatures. And that's important because when we think about urban heat islands, it's the continuation day and night of the warming that becomes so significant. Now here, as we're thinking about Gills Creek and the watershed, we've got ecological concerns and we've got human concerns. For the ecology of an urbanized watershed like ours, there are impacts on habitat suitability as you have areas that are very, very warm. We've got impacts on the metabolic rates of animals that are exposed to these extreme temperatures, and then fluctuations of very hot water running into the stream itself. I'll show you some satellite images in a few minutes that'll show you where the temperature on the skin surface of or the surface temperature of the watershed can be up to 153 degrees. And so imagine rainwater on that moving into what were cooler streams. But we're also interested in what this means for the walkability of the city, for outdoor recreation and work. We're talking about, we want to enjoy these new greenways that we keep we're hoping for, and expectations there. There are also issues about energy use and the cost of fossil fuels, as well as impacts on air quality. So all of these things are associated with these urban heat islands. And for those of us living in the watershed, it's a combination, not just of the heat waves that we so often hear about, but it's also the just chronically high temperatures that are important for human health. We often think about the young and elderly, but it's a significant continued exposure to high temperatures, not being able to get cool, and being in the heat for long periods of time can increase the odds of preterm birth for moms and the complications that their children experience, their families experience because of it. And it also matters that we've got lots of people in the watershed who have other diseases that are exacerbated by heat, whether it's heart disease, the diabetes, respiratory diseases, whether your medication actually makes you more susceptible to these things, whether you're working outside, whether you've got someone visiting from out of town who happens to be from up north and doesn't know that they need to get acclimated here. And we have significant racial disparities, both because people have different, because there are disparities in people's health, but also disparities in the places where people are living. Just to put it in a little bit more context about why we're worried about heat, extreme heat mortality here, this is an EPA economic damages analysis. It's one of the big dots, right? Of all the things that could happen around climate change, we sort of take it for granted here, but it is one of the big issues, and it will impact labor. So when we think about safety in our city, safety in our watershed, safety being outside, there's a lot of concern for the southeast. And expected that about a third of the labor costs are that'll be lost. Labor productivity will happen here in the southeast as people try and keep themselves safe in these changing conditions. It's also, again, an equity consideration because we're seeing the projected increases in cooling degree days. And already we've got people who are spending about 40% of their income on heating and cooling costs, where the thinking nationally is that about 6% should be what people are spending. So we've got a lot of reasons to think about it. And I've showed you images about the national issue and the global issue, but we're in Columbia. This is our famously hot city. And what's happening in the city is not the average of the county or the country or the globe. The city's special. We, typically you see images like this when we think about urban heat island, and we're saying, all right, we've got temperatures that are lower in the rural areas. We have more trees. They elevate a little bit in suburban areas with changing amounts of building, changing density of roads and so on. And then in the downtown areas where there's little vegetation, lots of buildings to absorb that heat and re-radiate it, it's much warmer. And this is, typically about 1 to 7 degrees Fahrenheit difference. Add some southern humidity to that, and you can already feel the severity of the differences around town. And we know where this comes from. The basics are that incoming solar radiation is absorbed by the buildings and then re-released. But we also have other activities taking place in concentrations in urban areas. Our cars are emitting heat. We've got our air conditioners on top of our roofs emitting heat. And we have a couple things happening to offset it. Tree temperature, the trees, we've got a little bit of a waterway, but this is all sort of the basics. And we know that there's a lot of solutions. Planting trees, rooftop gardens, vegetated structures, all these things can help in significant ways. So I'm focusing on these trees. You've probably seen numbers like these, but just to make sure we're all on the same page. In tree groves, you can get temperatures that are 9 degrees cooler than over open fields. Even grass is much cooler than bordering areas, so 2 to 4 degrees Fahrenheit. We're decreasing energy consumption. I'll talk to you about a study in Charleston where they saw that where they've been able to maintain forest areas, the temperatures are as much as 11 degrees cooler than areas that are in the city. And then we've got benefits from the trees, which are this key urban heat islands reduction strategy for air quality, as well as for stormwater retention and collecting rainfall. But so all that's the basics of it. We know there's the big picture, but then to get to these locally appropriate solutions, we need to look a lot beyond these kind of illustrations. And that's what I want to share more today. This is the city of Columbia in 2005. What we're looking at is a Landsat image taken by NASA. And what it shows is that urban heat island isn't that nice, continuous, even surface that we were just looking at. It's actually broken up and fragmented into these micro heat islands. So the temperature that we're looking at here is what they call the skin surface temperature. If you were to lay your hand on the pavement or whatever it is that's being reflected there, you'll see it was 121 degrees on this day. 53 degrees, you think it's kind of interesting, right? See that nice green stretch running through the image? That would be the cool water in the Saluda River being captured by the satellite thermal image. So we've got these, this sort of micro complex of different areas of heat. What we're seeing in Columbia is that heat island is expanding. This graduate student here in the Department of Geography, Alex Fulham, did these analyses comparing Landsat images again from Columbia in 2005, Columbia in 2020. And you can see where there's some spread further, particularly to the northeast, but also along some of the other urban corridors. Interesting enough, in a big picture, and this is a large part of the watershed that we're looking at that's being warmed this way. The next thing I wanted to share with you is the city, that what's happening with the City of Columbia's tree canopy. Now, using a different set of satellite images with a much finer resolution, we looked at where there's a strong tree canopy on the right, or on the left rather, just within the city boundaries. So it looks a little odd to see the blue in that sort of strange shape. That's because it's the boundaries of the City of Columbia. But we can see the blue against the red really clearly. So there are areas where there is not significant tree canopy. But we also know that over this time, there's been a tree canopy change. And the image on the right shows you where there's been loss of tree canopy. Now, this is super fine resolution imagery. This is capable of resolving trees at 1 meter square. So it could be a large branch and not a whole tree. And some of it's a whole large tree. But the pattern there is a pattern of, when you look at it close up, there are larger areas, and I hope you can see some of this, but there's also a number of smaller kinds of areas where the canopy is less available to mediate that urban heat island and be part of the solution for urban heat. The good news is that for us, adding or unfortunately losing trees in small areas can make a really big difference for our experience of the city and the walkability and the livability of it. Overall within the city, there's been 21.6% loss of canopy, 2019. Now let me give you the caveats on this before we go too far with that. The analysis is based on the current footprint of the city. And we know that between 2005 and 2019, the city brought lands in that may have lost canopy before the city was responsible for them. So just in terms of who was watching, how that was taking place. We know that some of that happened elsewhere as the whole region has been growing, and it became part of the city during the period of analysis. The second thing that we see here is, or we don't see very well, is that there's an ongoing planting of small trees. So those trees are there. They haven't yet achieved the full growth of some of them that we've lost. Many of us are familiar with having big old trees that just are aging out. And the other thing I want to know about this is that even though it's important and we're understanding where the heat islands are and seeing places where potentially you could strategically put in plants and trees and think about where the canopy most needs to be replaced and might have input. What we're not seeing here is the air temperature measurements or the humidity. This is, again, still that skin surface temperature. So to understand the lived experience of it, we want to get the air temperature as well. Now, what we're doing to get to that next step is I've been fortunate to be involved with many organizations, including and getting the support from many groups towards doing some additional heat mapping of the city. We're expecting a decision on a grant proposal in March, and these are the many groups that wrote letters of support so far. The work here is intended to help us get a better characterization of the urban heat islands so that we can think about where to do the tree planting and where there are opportunities for improving the overall livability of the city. I worked with the city of Charleston and the Medical University and many partners in Charleston this summer. And on one very hot day, we had volunteers go out in their cars and drive 18 transects through the city. They had sensors on the sides of the cars. And so they were measuring air temperature and humidity at 3 different times of day. So rather than one snapshot that I've shown you before, or I've already shown you of the temperatures, we're getting an indication of what's happening through the course of the day. And seeing that the heat is persisting overnight in different parts of the city. So there's the heat disparities within the city, and those impacts are there. Not a particularly large difference, maybe about 4 degrees difference in Charleston there over in the morning. As you reach into the afternoon, the differential becomes greater, and you can see the value of the large forested areas in the blue shades that are down in the, doesn't that sound nice? 87 compared to 95. We can see these areas there, and also the hottest zones. But the most clear differentials across this city
Just put in my credit card number.
are in the later evening, where we really see up to 11 degrees, simply in the temperature.
It's okay. I didn't realize that was an option. And then it said with the cancellation policies.
Somebody,
Um,
somebody's not
if we-
muted.
If
We
we're,
We need
oh
everybody
no, I guess it doesn't
to
matter.
be muted.
Yeah, it got a little weird, but
Excuse us.
so it's fine.
The host
Um,
should be able to mute.
I think I got it. Carry on.
Okay. So we've got we can find places where there's a much more significant temperature differential. And what I want to leave us there is with this improved mapping and with the opportunities to think about where we put trees and how we might address this urban heat island. We have a lot of opportunities, but we do need to understand where and when and under what circumstances we can move to reduce these heat risks. And I'm optimistic that with so many organizations interested in the importance of tree planting and urban heat island reduction, that we'll be able to move forward on that. So I've moved through quite a bit pretty quickly. I'm happy to go back and take any questions. Thank you.
Okay, Carmody, do you have any questions in the chat? And those of you who do have questions, please put them in the chat.
So the only thing that's come up so far is the slide that you have the heat island showing from 2020 versus 2005.
Mhm.
It looked like some areas actually ended up getting cooler in 2020 compared to 2005. Do you have any idea why that would be?
We think it's irrigation, frankly, that there's small areas over there. That's over near the Fort Jackson. I think that's near the Fort Jackson Golf Course. And I suspect we're seeing some irrigation in spots. That's our best thought, but we don't know when exactly the time, when the image was, what time of day it was taken, that kind of thing. These are hard to compare. I didn't go into the challenges of this is 20. These are both. Here we go. We do most of the darker greens are not in the 2020 map. So those cooler temperatures, but that's what we were thinking, is that it's more irrigation. Does that help? The other problem with these maps, of course, is that you can't take it on the same day and the conditions aren't identical. So one is July, one is September, There's a little bit of difference in the canopy coverage that accounts for some variation in it.
Mhm.
And then the days themselves, of course, weren't the same temperature either. We've adjusted the images here to make sure that the temperature scaling is more comparable than it would have been if we just shown you the raw images, but yeah, that's what we're getting at.
That makes a lot of sense. I mean, it certainly still shows that there's definitely heat island
Yeah,
effects.
there's heat island, it's scattered. I hadn't appreciated how scattered it was. And I also thought, for just purposes of that looking at some of these places, it's really clear where we have opportunities to address canopy and where it looks like it's going to be really hard. So we have large areas in the downtown with very little canopy cover at all. And, and significant challenges in putting it in there because finding places to plant trees where you don't have power lines, or you don't have something underground that will be destroyed by those tree roots is complicated in a big built up city like this one. So that shows there really nicely.
We have a few more questions that have come in. One is about humidity. So we have some model predictions for heat, but what about rainfall? We all know hot weather is harder to bear in high humidity.
The climate change expectations around rainfall are that we will see some increases in the more severe storms, but the models in the Southeast don't have strong agreement. The climate models aren't perfect, and some of their imperfections are particularly relevant for us. So there's not a lot of agreement there. But we do know that when you have warmer temperatures, you've got more evaporation, and there's plenty of moisture to be evaporated. So we're expecting that humidity to increase as well.
And then another question is, what kind of tree would a homeowner plant to best help the heat?
Okay, so here we are, clearly beyond my expertise, but the great news is that we do have a guide for heat choices, or the tree choices. Let's see, so I would recommend planting a tree that would fit to the east or west, to the east or south of your house. So give yourself some shade. Am I getting that right? To provide shade, west and south. Give yourself some shade in the afternoon. Give yourself some shade from this from the south to the windows and the roof during hotter parts of the day. It's one thought. So which tree will fit in which place is an important question. Often we think about a tree that would lose its leaves, so you get that sort of benefit of having it do more cooling when you need it in the summer and less cooling in the winter, when maybe a little bit of extra sun on the house or through those windows would be nice. And then what I'm seeing people recommend is that we look for trees that fit within this climate zone, but also consider the possibility of planting trees that are acclimated for one climate zone further south, so that the trees themselves we can expect to cope with anticipated changing conditions.
Debbie, sorry.
Yeah, go ahead.
Okay. Debbie shared that the South Carolina Forestry Commission has a good publication on urban trees that might be good to look at for that.
Yeah.
But you also alluded to a guide. Do you have an easy access link to that you could put in the chat, or is that something that maybe we could?
I can send that
share?
afterwards for that.
Okay.
Yeah.
Perfect. And then related to that question, what kinds of thought are being put into the best type of trees to plant to offset heat islands? I know you spoke to that a little bit, but do you know anything with respect to tree canopy, rate of growth, longevity, native versus non-native?
I think I don't know a great deal about that. I do know that there are lots of reasons why we plant native trees, because they're already conditioned to the heat and humidity and provide different habitat benefits, but maybe some of those that are also native a little bit further south, so that we know that this isn't the edge of their tolerance, would be a good solution. Let's see, what else do I know about that? The other thing that people are recommending is tree planting is a good idea, but to the extent that we can move in a direction that assures more tree preservation, it's also a good strategy, because those large mature trees are certainly doing more now than many of the new plantings will do for the next 10 years, 20 years, 30 years, right? To the extent that that's an opportunity, take that on board. Yeah.
That makes complete sense. And which SDG target do you reckon aligns best with mitigating urban heat island effect?
Sustainable Development Goal target. It aligns very nicely with, I think, concerns about health is one that stands out to me. To the extent that that's one, I haven't looked at those recently, so I'm not thinking of one right offhand. Somebody may have them on the top of their head a little bit better than I do.
And then another question is, to what extent are local governments thinking about adaptation to heat islands in South Carolina and elsewhere?
It's becoming more, people are becoming more and more aware of it, but it has not been, there's been a long-term awareness of heat islands. I can remember the conversations of it going back to the 90s, but the more focused attention on it has really come about in the last 5 to 10 years, as we start to think about the impacts of climate change coupling with urbanization and a better understanding of the heat and health disparities around the areas. So this is where we have the NOAA program that partnered with so many people in applying for, raising the profile of it, and many cities working to understand this. It's that said, there's cities that have done a lot with it, but it tends to be the least well incorporated of the climate related hazards in planning at this point in time. There's much more work typically around flooding or other kinds of events, more extreme events. Heat is so chronic, it doesn't quite get the same attention unless it's a heat wave, and then it becomes a disaster. But this ongoing high level of heat that causes chronic stress isn't getting the hasn't been a real focus yet. We're getting there. Charleston just completed this heat mapping study. They're doing a number of things around looking at canopy coverage and thinking about how they're going to integrate tree planting along with other strategies to address the flood conditions down there. So they've got a lot, quite a bit going on towards just improving maybe training for guides who are bringing unacclimated people into the city and having them, move through the city and understand where they're, what the symptoms are and how you should be better prepared just to take care of them. The medical university down there is looking at things like the choices of what sort of surfaces you would put when you build something. What are the appropriate surfaces? Stay away from some of these dark colors that absorb a lot of heat. Look at particularly how we treat areas where people are standing for a long period of time outside, whether it's the outdoor lunch area or whether it's the intersection where people have to stand in temperatures for a long period of time while they wait for the traffic light to change. They're particularly concerned because many of their patients, people are coming to the medical university often because they're not well. and they do not need the additional heat stress on top of whatever it is that they're working with. So we're seeing quite a few things happening, but I'm hoping we'll be able to do more.
So there's research about grasslands and their good effects, and that grassland plants may be more appropriate in some urban or suburban areas than trees. Do you have any information there? Southeast Grasslands Institute is one organization from Tennessee doing this research.
I know that trees aren't the right answer everywhere. And one of the, if we were to think about how we measure heat, we often measure temperature and humidity, and we think about the relative temperature. But when people measure the full impact of heat, they like to measure the wind speed as well for evaporative cooling. And they like to look at direct solar radiation too. So sometimes trees, when they actually block the movement of breezes, or too dense, can also, there's a sort of a complicated relationship there. When it's good to have, the recommendation is often to have trees with grasslands so that you have the movement of air as well as the shading that you get from a good balance of those two things. So I don't know more than that. I know that we do need to balance it and think about how those things happen together.
Another question we have is blue-green infrastructure is one efficient and effective method of mitigating urban heat island effect. As per you, what are the best examples or cities like sponge cities in China that do that?
I think it's a really interesting choice about how to capture the water at the same time. Again, that would be an area where I think other people may have looked more deeply into how that would how that could be done, and whether or not that was a locally available solution for us. I would say that in terms of blue infrastructure and urban heat islands, one of the things that we learned from the Charleston work is that while water features do local cooling, the really detailed fine-grained analysis they did showed that those water features tend not to have very much influence beyond about 200 feet away from them. So you can get some cooling for a relatively narrow buffer around those features. So as we think about, do we need more fountains? Well, we need respite areas. We need to think about them being available to everybody and carefully chosen, but they're relatively confined.
Another question, do you have any ideas on how to cool the hot water that's dumped into Gills Creek Watershed?
The hot water coming off the roads and so on. I think that's what we're talking about. So any of that heated storm water that comes off exceptionally hot pavement, the best idea is to slow it down and let it cool off before it moves into those watersheds. So those opportunities to either have it captured in storm ponds, slowed through, passing through riparian buffers or something else that releases some of that heat and diminishes the total amount of that hot water going into the watershed. Good strategies there.
Wonderful. And our last question is, how do we succinctly capture the message about preserving existing trees when it comes to convincing neighbors not to cut trees down because they're messy or might fall on the house, et cetera, et cetera?
I think what we talk about is those multiple values, right? That tree, at the same time, it's a little bit messy. You take away that tree and your air conditioning bill is going to go up. So which is the bigger motivator, the leaves or the tree? And I think just helping people see those benefits that are often kind of underappreciated until you take the tree down and you're like, wow, that was a lot of shade that provided. I wish that was still on my roof and my air conditioning bill wasn't quite the same. I think helping them to recognize that there's some things that are happening, yeah, just sort of out of sight. Not quite so, those ones that are less visible, and reminding them that those are there as well. And it's an important trade-off if they're going to make that decision.
Wonderful. Well, thank you so much, Kirstin. I can say how this has been super enlightening. And I thought it was really interesting how the heat islands last even through the night, more so in certain areas. That's not something that I had thought about previously. So all across the board, thank you so much. And thank you to everyone else who's participated in our webinar today. We had some really good questions and discussion.
Thank you all.
And if you, sorry, go ahead.
Oh, I just want to say thank you too.
Oh, thanks. And if anybody has any further questions for Kirstin or for us at Gills Creek Watershed Association after this, then please feel free to reach out to any of us. We will continue to have our monthly webinars, and you'll be able to find those to pre-register on our Big Splash newsletter, which you can sign up for on our website. And you can find them on social media and on our website. And we do have a very fun fundraiser coming up, our Wine for Water event that you definitely will not want to miss. It'll be on March 24th, and it'll have a silent auction, music, food, and of course, wine. So you can purchase your tickets for that to support our efforts to protect and restore the Gills Creek watershed through our website via Eventbrite. So hopefully we will see you all again there. And thank you again, Kirstin, and everyone for attending.
My pleasure. Thanks, everyone.
Thank you.
Bye all.
Thank you. That was wonderful. Thank you.
Bye, everybody.
Really look forward to more of these. Thank you so much. It's the first one I've attended, so I really appreciate it.
Glad to hear it.